Hey Josh, how's it going?
It's going all right. But I think of like
Yes, it's right here.
also I don't know when I tried to sign up for OpenSim, the email link doesn't link.
Oh, really? Oh, okay.
This is the weirdest thing. Can I show you?
Yeah.
Because I did all the stuff, and then they send you the email and then it's not a link.
Oh. Oh, so you can't even make it.
It's exactly because it says thank you for creating your account. Click on the following link, but it doesn't.
That could be Microsoft or Outlook also masks some of the URLs. So that might be the issue. I'll put the installer in a Dropbox for later. Then you can do that.
Because I was just thinking like, oh gosh, what am I gonna do? Try that. Because like there were many ways things could have gone wrong. This is not one I had anticipated, but it just when the link to install.
Or even just to make the account.
Oh yeah, the link to make your account doesn't even link.
Yeah, because I mean I've been part of SimTK for a while, so I didn't know there was such an issue with making.
I'm not sure how come it is, but I just know that out of nowhere. So like I went to the account, and then I was just like, I don't know if this happened.
That is very strange.
Thank you though.
Yep. Let me put this.
Out of curiosity on the exam, like I know everything was right. Oh, can I take my?
Oh yeah. Yeah.
Was this overkill or was I actually supposed to show exactly up to here?
Yeah. No, but you're supposed to do
Okay, I wasn't sure because I was like, at first I'd stop a little early and I was like, there's so much space given. I was like, he probably wants us to show all the ones like finding, the Y.
Oh yeah. That's
Okay.
that's why I gave you so much space to do
I
that.
was like, wait a minute, I finished with space left. I started feeling suspicious because I should never finish with space left. Anyone does. Okay, cool. That's what I thought. I thought that was a pretty chill game, but the line was interesting too.
Yeah.
Professor,
Hey, what's up?
I had a question about the project.
Okay.
So for our group, we're doing the ostrich biomechanics,
Hmm.
and I wanted to know if you wanted like just the general biomechanics of the ostrich, or if it's like a specific scenario, like if it was like walking or running.
Yeah. So in for the report, you need to do five biomechanical analyses in total. So usually, people will look at specific situations, like maybe an ostrich standing up, or maybe an ostrich keeping balance, or in the middle of a run, and then
Yeah.
they'll do each one of those as an analysis. So for your introduction, you do need to discuss just the general biomechanics of the ostrich. But for your calculations, usually you do those for specific scenarios.
Okay. So just for the analysis part, we would have different scenarios.
Yep. Hmm.
Because I was also looking at one of the examples that you posted, the prosthetic arm, and they
Sorry, can you
had
say again?
I was looking at the examples in Canvas. One
Yeah.
of was the prosthetic arm,
Yeah.
and it had two different scenarios where it was the the prosthetic arm versus like a regular arm,
Hmm.
and then they had five different scenarios where it's the static analysis and then the inverse dynamics and then the muscle force. Would
Hmm.
that also be like viable?
Yeah, of course. Hmm. Yep, that's
Okay.
definitely a good approach. That's why I posted that example, because I think that's a good approach for a lot of people to take.
Okay. Yeah. All right. Thank you.
Yep. Hmm.
Actually, I had a question about more about the presentations.
Hmm.
So, as far as the presentation, I know you said that we're not supposed to like be completely finished, but like, what do you expect us to like to present since our reports aren't supposed to be completely done?
So the presentation has less, I think, analysis. So I think the final report requires five, but for the presentation, you only need three biomechanical analyses. So usually people pick three relatively easy analyses for that one, like static analysis, is usually the easier one. And then for the report, for your last two analyses, that's when they do something more complicated, like an inverse dynamics or an optimization analysis. Um, all the other sections, like the introduction, the background, those should all be relatively complete.
Oh,
When I say that, it doesn't have to be fully complete. It's usually when you write a report, you provide a lot more details in terms of the background and things like that. Before the presentation, it's only 15 minutes, and so you can only share so much in that time. Um, so actually, someone reminded me today, I did not post the template, and so I was going to mention that at the beginning of class today. There is a presentation template that's on Canvas that you can use. So this kind of has the overall format that I kind of expect.
okay, that's awesome. Yeah, so
Hmm.
thank you.
Yep. Yep. Mhm. All right, it's 4 o'clock. Let's go and get started. All right, good afternoon, everyone. I guess for the last time in this room. So, next week we're doing final presentation. So it's the last time we'll be in here. How's everyone doing today? Doing good. Okay. All right. So today is an exciting day. I've been wanting to do this in this class for a while, but we just always never really had the time. We're going to be doing a tutorial in OpenSim. Okay. So OpenSim, that was the software that we were talking about on Monday. It's a software that you can use to simulate biomechanics. So I do have a PDF posted online, so you can find this on Canvas. And so actually, if you go to the Canvas site here, you go to week 15, you'll see that there is a PDF for you to see here. Okay, so I'm basically going to be going through this PDF. But also this PDF is just kind of almost like a transcription of the online tutorial, which I've given the link here as well. So I've added, it's almost a one-to-one kind of transcription, but I did add a lot of my own comments, especially cases. I did add a few screenshots too, where it was a little bit unclear, but it's very similar to what's on the website. Okay, so we're going to go through this together. This is kind of just an introduction to OpenSim, and the hope is that you'll be able to pick up something from these tutorials today that you can use for your final project. Okay. Granted, it's not a requirement, so you don't need to use OpenSim for your final project, but it can take the place of one or more of the biomechanical analyses that you have to do for the project. So something different that you may want to do. Okay. All right, so before we start, I do want to make an announcement. So I actually realized today that I forgot to post the final presentation template. Okay, so a few people have been asking me about the exact format for the final presentation. So I did post kind of a skeleton kind of slides that you can use, right? So you can access this from the Canvas site under the assignment page for the final presentation. So if you go there, now there are 2 files for you to download. There's one file for the rubric and the other file for the template. Okay, so you can click on the template here. It's very bare bones, and so please don't just use this theme. Make it look a little bit nicer, right? And fill in everything here. But you can see here the template here is just to let you know about the order in which I expect you to kind of present your information. So first, you want to give your introduction and background, and here's just some information about what to include. Then you launch into your biomechanical analyses. So remember, for the final presentation, I only need 3 of them. I was telling someone before the class, usually for the 3 analyses that you do for the final presentation, usually people do some of the easier types of analyses, like static analysis, right? So you do biomechanical analysis 1, 2, and 3. Oh, well, there's only 2 here, but there should be a 3rd one. Okay, and then there is a discussion where you discuss your results and a conclusion. Okay. So this template here is just the order of the slides, and so I expect you to have more than 1 slide for introduction and background. You should have more than 1 slide for introduction and background. This is just where it is in the in the order. Right? Question. Okay, my bad. So the rubric does say 2. So yeah. So for the presentation, there is only 2 biomechanical. Now, for some reason in my mind, I think it's 3. But yeah. So excuse me. So it should only be 2. So the template is correct. The template's correct. You should only have 2 biomechanical analyses on the presentation. Okay. Okay, so that's there for you guys, just to show you kind of the order of things. Any questions on that? Or hopefully everyone got the presentation order for next week, so everyone knows whether you're going on Monday or Wednesday. And remember, the presentations next week are going to be purely virtual. So you can all present from the comfort of your own homes. I've had groups get together all in one physical place and present together on one screen. That's fine too. But I won't be here. Well, I'll be on campus, but I'll be sitting in my office. So the presentation will be delivered virtually. Okay. If you're presenting on Wednesday, then you can submit later. Well, so the slides aren't due. The slides themselves aren't due until Friday. So no matter if you're presenting Monday or presenting Wednesday, if you want to kind of, fix up your slides a little bit before you actually submit them, I'm giving you until Friday to submit the slides. Okay. All right, any questions I can answer about the presentation or just anything before we get started? Okay, all right, so so the subject for today is we're going to be doing an OpenSim tutorial. And I actually uninstalled OpenSim from my computer just to kind of show you a fresh installation. Okay, so I know I just realized today that some people had some issues downloading the software from the website, or I guess more specifically making an account from the website. They sent you a link that you couldn't click. So right before the class, I did send a link to a Dropbox folder where you can download the installers for Windows or Mac. And so if you do want to follow along, it's pretty lightweight software, so you should be able to install it, pretty quickly after downloading the executable. But once you download it and install it, it should show up as a application on your machine. Okay, so the version of OpenSim that we're on right now is 4.5. So I'm gonna go ahead and click this and open up the software. Fun fact: the author of this software actually is good friends with an artist, and so if you ended up getting the textbook, you should see that there are a lot of really pretty illustrations in the textbook. That's because the author is best friends with an actual artist. Okay, so the reason I wanted to do a fresh install is this reason, and so the first time you launch OpenSim, it's going to ask you where you want to install your models and scripts. And so, this is only a one-time prompt. And so you want to make sure that you don't click away from this. And so by default, OpenSim will install these models and scripts in your documents folder. So I'm on Windows here, so it's going to install on Documents, OpenSim 4.5. So if you want to move this, and so if you want to move it to your desktop, that's fine. But just make sure that you know where this location is, because we're going to be referencing them during the tutorial. Okay. Okay, so I'm gonna go ahead and hit OK, because installing the models and in my documents folder is fine. Okay. All right, and so from there we come up to the OpenSim interface here. So in the world of engineering softwares, open source, OpenSim is actually a pretty clean software. If I end up teaching my cardiovascular class next semester, you'll see another software in that class which is not clean, and so that software is kind of a mess. So OpenSim is actually very, very nice, compared to that. Okay, so let's kind of familiarize ourselves with the interface first. Okay, so the first thing to notice here is this kind of very big window that kind of takes up the majority of the screen. Okay. So this window right here is what's called the visualizer window. Okay, so this window is where we're going to see all of our anatomic models, right? And so you're going to see skeletons there, you're going to see muscles, and so that's what this is for. Okay, let me change to red so it's a bit more visible. All right, so the other area here that is important to know is this area on the left right here. Okay, imagine that box, perfectly encapsulates that area. So this area, I'm going to refer to this area as the navigator window quite a bit. Okay, so this is where we're going to see our models organized, and that's where we're going to access all the muscles and stuff. Inside this area too is also an area called the coordinates window, which is what we're going to use to actually, affect motion in the model. Okay. So we're going to be visiting this top left corner of the screen quite a lot. So this is where the navigator window is and the coordinates window. Okay. Okay. So a few other areas that are a little bit interesting. So this top area right here, this is known as the toolbar. Okay. So once we load in motion data, this is where we're going to play it and animate it. Okay. Down here on the bottom left, we have the properties window. So we're not going to do too much with that in this tutorial. But when you are kind of loading in things you want to change, like lengths, this is where you would do it. Okay. And just like any other program, there is kind of a top section here with your usual kind of commands here. So file, edit, tools. So we'll be going up there as well. Okay. So that's just kind of a very quick rundown of the interface. And so, I'm going to be calling these windows by name. You'll see my mouse kind of move around there as well. Okay. So first thing we have to do is we have to load in our musculoskeletal model. Okay. So OpenSim has the ability to simulate movement for all the different parts of the body. But most of the time, you want to focus on just one particular area or one particular part. Okay. Like I mentioned, like we talked about on Monday, the human body is comprised of, hundreds and hundreds of muscles. Oftentimes it's not really practical to load in all of those things. Okay. So for this tutorial, we're going to be working on a model that is going to simulate the walking gait, right? So we're going to look at a person walking. Okay, so to open up a model, you're going to go up to File in the top left corner of the screen. You're going to go to Open Model, okay? So if it's your first time installing the software, it could take a little bit of time. Okay, so the nice thing about OpenSim is that, if you remember where you installed your models from before, when you click Open Model, it should take you to that location by default, okay? And so you can see here, let me just go up a couple folders, okay? You can see here that we are in my Documents folder. It created a folder called OpenSim. We're in version 4.5, okay? So in here we have two folders, one folder called Code, the other folder called Models. And so the one we want to load in is Models. Let's go ahead and double click that. Okay. And wait for it to load, I suppose. Okay, good. Okay, so OpenSim comes packaged with a lot of kind of models by default. And so for a lot of your guys' projects, you'll probably be able to use, one of these models for, one of your analyses, okay? Especially if you're doing human movement. So, all these models are human models, if I'm not mistaken. I haven't checked all of them, but, I'm pretty sure they are. So you can see we have some of the wrist, we have some of the arm. There's a lot of lower body models. And so the one that we're going to do today is for lower body. There's one model specifically for a soccer kick. And there's some that are named after people. So, most likely there's going to be a model here that relates to your project. Okay. But for this tutorial, we're going to be working with this model right here. So this is called the Gate 2392 Sim Body. So let's go ahead and enter this folder. And I have no idea why it's being slow, probably because I just installed it. Okay. So inside this folder of Gate 2392, you'll see that there is a single file here. There's a folder. So we're going to go into that folder a bit later. But the first thing we need to load in is the model itself. And so the model file for OpenSim has the file extension .osim. Okay. And so you can see here we have one model here, the Gate 2392 Sim Body .osim. So let's go ahead and open this model. Okay. And you give it a second to load, and then now we have our model here, okay? So here is our model. So it's a little skeleton-looking dude. He has no arms. He has just legs, okay? And torso and a head, I suppose. And he has a lot of muscles, okay? So each of these red lines that you see here represents a muscle for the lower extremity, okay? And you can see here that we've included, some muscles in kind of the abdomen as well. Because some of these muscles affect the flexion of the hip. Okay. Okay. So for those of you that have downloaded it, were you guys able to open a model? Okay, good. Okay, so let's take a tour here because there's kind of a lot to kind of take into account here. So first thing, let's talk about how to navigate around the visualizer window. Okay. That's probably the first thing everyone wants to do is they want to look at the skeleton's butt, right? And so if you want to rotate the camera around, if you want to rotate the camera around, the way to do that is you left click on your mouse and you just kind of drag it around, right? There are controls for trackpads as well. So, a very impressive thing that OpenSim was able to make controls for trackpads because that's not easy. And so if you want to rotate and you're using a trackpad, it's just a single finger click and you hold, okay? All right, so the other operation that you can do is you can pan the camera. So a very useful thing, especially if, you know, for mechanical engineers, we're all used to using SolidWorks. So panning the camera is a very useful tool. So the way to do that with the mouse is that you can right click on your mouse and then drag it around. So that's how you pan the mouse. Okay. And if you're using a trackpad, either a Mac trackpad or a Windows trackpad, it's a 2-finger click. Right? So you click with 2 fingers and you just kind of drag it around just like that. Okay. All right, and so the last thing that you can do is you can zoom, okay? And so zooming with the mouse is pretty straightforward. So most mice nowadays comes with a scroll wheel. And so you just simply scroll up and down on the mouse. And so that will zoom the model in and out. And then for the trackpad, you know, the action is pretty intuitive. And so you basically just pinch and expand. So just exactly the same way that you would zoom on on a typical Mac. Okay. All right, and so that is the camera controls. Right. Next thing let's take a look at is let's take a look at the navigator window. And so one thing you should know is that after we loaded our model, we have kind of an area up here that kind of populated. So we have our 3D gate model 2392. Okay, so this is expandable. So I'm going to go ahead and click on this plus arrow to expand the contents. Okay, and you can see here that this has a lot of data and a lot of information. Right, so we're not going to go through all of this, but you can see here that there is information about the particular body parts. So this section here shows all the body segments that are present in the model. Okay. There is another tab for the joints, and so this will show you all the joints of the model. Okay. There's a way to look at all the forces or the muscles. And so muscles are a little bit harder to find. And so the way to find the muscles is you have to expand the menu for forces. Okay. And then under forces, there is another menu here for muscles. So let's go ahead and expand that. And you can see all of the muscles that are here. So it's quite a few muscles, right? Remember, each line here kind of represents a muscle. All right, so next thing we're gonna do, let's find out, or let's let's learn how to view particular muscles here. So right now, what you're viewing is all the muscles that are present in this model, and it's kind of a lot to look at. Okay, sometimes you want to view just a very particular muscle, especially if you're kind of new to the anatomy and you're kind of wondering where a particular muscle is. This is a great way to kind of visualize it and learn. Okay. Okay. So let's take a look at all the muscles that are responsible for knee extension. Okay. And so if you look in the navigator window here, you can see here that all the muscles are actually grouped. They're grouped by the type of motion that they affect. Okay. And so for instance, this group of muscle right here, the R hip at ABD. Okay. So this is the group of muscles that is responsible for right hip abduction. So basically, the right hip is this one. Abduction is basically rotating the whole leg out this way. Okay. Remember we've talked about before that, there's a lot of redundancy in the human body. So, not just one muscle is responsible for that. We have a group of muscles for that. Okay. So if you expand this, you can see here that there are, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 muscles that actually affect the right hip abduction. So very simple motion, but several muscles that do that. Okay. Okay, so let's look at the muscles that are responsible for right knee extension, just because the list is a little bit shorter. Okay, so if I expand this list for right knee extension, you can see here that we have 4 muscles. Unfortunately, because the muscle names are so long, we have to kind of abbreviate them just for brevity. But this right here stands for rectus femoris. This stands here for vastus intermedius. This muscle here is vastus lateralis, and this is vastus medius. Okay. And so if you want to highlight just those muscles, we can right click on that muscle group, and then a menu up here will pop up that says display. And then you can click on show only, right? And so what this will do is this will hide all the other muscles in the body and just highlight that muscle that we are looking at there. Okay. So you can see here that after I've clicked on that, show only, we can see the 4 muscles here that are responsible for right knee extension. Okay. So you can see here, all these muscles are on the front of the thigh. So you can see all of these are basically quadricep muscles. Okay. All right. And so of course you can kind of play around with this as well. So you can kind of see the all the muscles for, you can see the muscles for right knee bending. Okay. You can see the left side, of course, too. Okay. So let's look at the right and left hip extenders. Okay. Right. So definitely feel free to kind of play around with this a bit. Right. Any questions on this so far? Okay. So yeah, so I know we've been talking a lot in the class about how many muscles there are in the body, but hopefully this kind of shows you just how many there are. Okay, so when you want to show all the muscles again, you can right click on all. So all is a special group of the muscles here that contains all of the muscles. And then you click on show. Okay, so that'll bring up all the muscles again. Okay. All right, so that is an introduction to all the muscles in the body. Let's do some movement. All right, so to kind of move the model around, we're going to need to go into this coordinates tab right here. Okay, so it's a little bit easy to miss, and so I'm going to go ahead and highlight it with my pen because it's kind of right next to the navigator window. But if you click on this coordinates tab, you're going to see that the navigator window is going to change to this interface right here. Okay. Now there's a lot to look at here. So there's a lot of different sliders and a lot of different names. So, let's kind of go through each of these individually. Okay. So, we know from the class that, the way that we typically characterize, the movement, the way that we characterize kinematics of the human body is through joint angles, right? So for instance, and so let's say that we want to flex the knee, right? And so if we want to flex the knee, the way that we would do that is we would go to this entry right here, which is knee angle R. Okay. And you can see here that there's a slider. And so this slider here represents the range of motion. So right now it's fully maxed out to the right, or almost fully maxed out. Okay. And so if you want to bend the knee, you would basically take this slider and just kind of drag it to the left. Okay, so I'm gonna drag it slowly and watch what happens to the knee here in the visualizer window. And so you can see here as we kind of extend the knee or flex it, this model is moving. And what's cool is that you can actually see the muscles are actually reacting as well. So if you look at some of the muscles in the quadriceps, you can see that they're actually changing length. They're actually kind of changing their path a little bit, exactly how it would be kind of in the human body. Okay. We can take another, a motion here. So let's look at hip. Let's do a fun one. Let's do hip adduction of the left hip. Okay. Okay, so this is the left leg. So this is going to affect the other leg here. So let's go ahead and move this slider to the left. Okay. You can see here it's kind of doing a, little can-can dance, I guess you could say. Right. All right, so this is kind of the cool part here. So, you can kind of manually kind of move the model around. Okay. So of course you can do some fancy things here. So, if you want to simulate a particular, motion that starts from a particular pose, you can of course move these sliders to kind of affect that motion. So, let's say that we want to, look at, maybe the skeleton kind of in mid jump. Okay. So let's move the right knee back and let's also move the left knee back as well. Okay. Right. So this would be the pose that this person would assume, if they were kind of mid jump. Okay. All right. And the cool thing is that you can actually save these poses too. And so if you wanted to kind of start an analysis from a pose like this, you can save it. So from the coordinates window, there is a button here called poses. Okay. And then what you can do is you can click on poses and you can click on new. Okay. So I'm gonna go ahead and click on new. So I'm gonna call this pose jump. Okay. Now it basically saved this pose. And so if you wanted to come back to this pose, you can click on jump. Okay. Or if you want to return to the default, you can just click on default, just like that. Okay. Okay. All right. Any questions on that so far? Okay, good. All right. So this kind of brings up an interesting point. And having a software like this, it makes it actually really easy to kind of visualize. Okay. Okay. So let me go ahead and clear all my drawings here. Okay. All right. So one thing I want you to notice is that if you look at most of the muscles in the body right now, okay, you can see that most of them are represented by a single what we call line of action. Okay. So a line of action for a muscle basically is the connection between where the muscle originates and where the muscle attaches onto the bone. Okay. And that line of action there represents the direction of the force when the muscle contracts, right? So that's kind of exactly how we've kind of assumed, throughout this class, right? So most muscles will only have a single line of action, okay? But, there are some muscles that actually have multiple lines of action, okay? So actually, let me show you what I mean by that. Okay, so let's go to, let's look at the right hip abductors, okay? And so, in fact, let me go ahead and highlight all the gluteus medius muscles, okay? Okay, so I'm gonna go ahead and show these only, okay? Okay, so all three of these, muscles here, or all three of these lines of action actually belong to the same muscle, okay? So the gluteus medius is a really fascinating muscle. It's kind of like a triangular looking muscle kind of on your backside, right? And so the muscle kind of looks approximately kind of like this, okay? And its fibers all kind of run in kind of that fan shape, okay? So because the gluteus medius is, it doesn't have a single line of action, the way that OpenSim actually simulates it is by, putting three different lines of action. Okay, so they put one line of action at the edge, the other line of action at the other edge, and then, one kind of right down the middle right there. Okay. So some muscles, if you ever see the convention within, within OpenSim that has, 1, 2, or 3, that usually tells you that all of those, lines of action belong to the same muscle. It's just the muscle itself is kind of broad, so you can't really just represent it by one line. Okay. Okay. Oops. Okay. Good. Okay. Another thing that's kind of fun to do is you can actually translate and rotate the model as well. So, we've gone over how to rotate individual muscles, but sometimes, there may be situations where you want to move the entire center of mass of the model itself, okay? So, this can be helpful when you're comparing two different models, which is what we're going to do at the end of class today, okay? And so if you look at the first 6 sliders here, okay? And so the first 6 sliders under the coordinates window is corresponds to pelvis tilt, pelvis list, pelvis rotation, and then pelvis TX, TY, TZ. Okay. So for this particular model, the pelvis represents kind of the center of mass. So if you move these sliders, it'll actually move that center of mass and actually move the entire model itself. Okay. So for instance, we can move this model in the X direction. And so if we slide this slider here, you can see the entire skeleton is kind of moving in that X direction, okay? You can also move it in the Y direction, okay? So we can kind of go up and down just like that. This looks silly, kind of clipping through the floor. And of course, you can move in the Z direction as well, okay? Okay. You can also rotate the entire body as well. So it's gonna look very silly for this one because, this is more or less kind of a full body model. But for some of the smaller models, and so, for a biological model that's of the wrist or the hand, sometimes you want to rotate the entire model to get it into a more convenient position. And so that's what these first 3 sliders actually do, okay? So for instance, if I move this slider for pelvis tilt, you can see that the entire body kind of rotates just like that, okay? You can do the same thing for pelvis list, okay? And then pelvis rotation, kind of rotates around that way. Okay. Again, these all look kind of silly just because this is a full body model, but the capability is there. If you want to reset your pose, remember you can always go to poses and then default. Okay. Okay. All right, any questions on this so far? Okay, one other thing that I want to show you before we kind of move on to plotting stuff is that there are some muscles here that actually cannot just be represented by a single line. Okay. Because some muscles in the body, most muscles are actually pretty straightforward. So they have a point where they originate and another point where they insert. Okay. But there are some muscles that have to actually wrap around some certain joints or some certain bony appendages, okay? So the right knee extenders are actually a great example of this because, the right knee extenders actually have to wrap around the patella, okay? So I don't know if you remember, we talked about it, I think, very briefly, maybe midway through the semester that, your quadricep muscles are actually quite fascinating because there's normally a patella bone here and they actually have to wrap around that. Okay. Now you can't see that in this configuration because the leg is straight, but let me kind of show you something. So let me take the right knee extenders. Okay. So let me just kind of highlight these muscles by themselves. Okay. And then what I'm going to do also is I'm going to flex at the knee. Okay. So let me look at the right knee angle here and let me flex it. Okay. So I'm flexing it. I'm bringing that angle all the way back. And what you should see here is that, these muscles, actually wrap around, that patella. Because remember, the patella is a, bone that's typically right here. Okay. And so because these muscles have to wrap around that, OpenSim actually takes that into account. And so when you're computing, let's say you're doing like an inverse analysis, the direction of these forces actually change depending on where you are on that muscle fiber. Okay. So that's kind of important to note as well. Okay. All right. So that's kind of an introduction to muscles and poses and moving things around. Let me go ahead and show all the muscles again. Okay. OpenSim is also very snappy. It's things you don't have to wait too long in the GUI once you kind of click a button, which is quite nice. Okay. Okay. All right. So let's go ahead and move on. So one of the nicest features within OpenSim, and probably the feature that most of you will use if you are going to use OpenSim for for your project, is OpenSim has the ability to create these nice plots for you. Okay. Okay. So to open up the plotting tool, we're going to go to Tools from the very top. Okay. And then you can see here that the first option under Tools is Plot. And so I'm going to go ahead and click that. And so the plotting tool is going to bring up another window like the following. Okay. And what you can do from this window here is you can plot various quantities against each other to do some really interesting analysis or interesting comparisons. Okay. Okay. So for example, one thing that we can plot here is the fiber length of a muscle as a motion occurs. Okay. Okay. All right, so before you start plotting, make sure you're in the default pose, and so make sure you reset the pose. Okay. Okay, and then let's come to the plotting tool here. So the way to use this plotter here is very similar to how you kind of imagine like an Excel spreadsheet is designed. Okay, so you have to specify a Y quantity, you have to specify the X quantity, and then you just plot it from there. Okay. Okay. So let's do an example here where we use the plotting tool to measure the length of the muscle fiber for two muscles in the leg. Okay. Okay. So first thing we're gonna do is we're gonna click on Y quantity here. Okay. And you can see here we can plot various quantities from this model. And so the one that I want to click here is I want to let's plot the fiber length for particular muscles. Okay, so I'm going to click on fiber length for the Y quantity. Okay. Since fiber length is a muscle quantity, we need to specify which muscles that we want to measure the fiber length for. Okay. So after you select fiber length, the next menu here will become selectable. So go ahead and click on muscles. Okay. And you can see here a long list of muscles that appeared. Okay. So this list of muscles is it's a little bit hard to use just because there's so many of them here. So we'll most likely have to sort this this list. Okay. Okay, so just to kind of sort this list here, the way to do that is to first click on this radio button here for model. So go ahead and click on that. Okay. And from here, you can sort by the muscle groups of this particular model. Okay. Okay, so the muscle group that we're going to be looking at here are the right knee extenders. And so you're going to use this, this menu here to click on R knee extended. Okay. I'm going to click on that. And so you can see here, there are 4 muscles here that are responsible for right knee extension. Okay. So the 2 muscles that we're going to plot here are the rectus femoris muscle. So that is this first one here. Okay. And the vastus medialis muscle, or excuse me, vastus intermedius muscle, which is this one right here. Okay. Okay. So of course you can plot the other ones as well, but you know, these 2 muscles here have kind of sufficiently different results. So let's go ahead and select these. So after you've selected those models, you can go ahead and close this window. Okay. And you can see here that those 2 muscles are added to this menu here. Okay. So next thing we need to add here is the X quantity, right? And so for this particular example, we want to see how the lengths of the fibers of these muscles change as the knee gets flexed. And so as the muscle goes through a knee flexion movement, okay? So for this X quantity here, you're going to search, and you're going to search for knee flexion R, okay? Or excuse me, knee angle R, which is this one here, okay? Okay, cool. Let me see if I'm missing anything. Okay, another thing you can do, you know, and this is useful mostly for your reports and for your presentations, is that you can change the title of the figure. Okay, so to change the title of the figure, you can go to properties here, and then you can go ahead and change the title. So for this one, we're gonna the title for this plot is going to be fiber length versus knee angle. All right. So we've gone ahead and changed the title. We've gone ahead and added all of our quantities. Let's go ahead and plot it now. So to produce a plot, after you've specified your X and Y quantities, you're going to click on Add. Okay. And then by adding, you can see here that we've added the 2 entries to our plot. Okay, so I realize for the people, actually, you know, for everyone, so for people here in the classroom and for people on Zoom, this is a little bit hard to read. So let me go ahead and expand this a little bit. I'm working with a little bit of a delay because my laptop screen is too dark, and so I'm actually working off the podium monitor here. Okay. Okay, so what you can see here is that the fiber lengths for each of these muscles decrease as the knee flexion angle increases. Okay. Okay, so let's see if this is true. So what this is telling us is that as the knee angle, you know, goes up, then these muscles are all getting shorter. Okay. Okay, so let's kind of verify if that's true. So let's go ahead and let's highlight those 2 muscles. Okay. So the 2 muscles that we're looking at here are the rectus femoris and the vastus intermedius. So let's go ahead and show just only these 2 muscles. Okay. Right, so let's go to the the coordinates window now, and let's change the knee angle. Okay. And let's see if this plot is true. Okay. Okay. So you can see from the slider here that the knee angle actually starts at a value of almost 10, and so it's kind of at the right-hand side of the plot. Okay. And so if we look at the plot here, you know, a knee angle of 10 corresponds to this area of the plot right here. Okay. So what this is telling us is that if we change the knee angle and we kind of make it more negative, and so we basically bring it towards minus 120, which is kind of the extreme, then all these muscles should lengthen. Okay. Right. So that's exactly what this plot is telling us. And so, you know, as the knee angle changes from 10 all the way down to negative 120, then the fiber lengths or the overall length of the muscle is going up. Okay. Okay, so let's see if that's true. or at least let's see if we can kind of verify that visually. Okay, so here are our two muscles. Let me go ahead and let me just find it. Oops. So I lost my model here. There it is. Okay. So let's go ahead and zoom in here. And so as I change this angle here, these muscles should visually lengthen, okay? Okay, so I'm gonna do it slowly just so that you can see. So let me go ahead and click the slider, okay? You can see here that as I'm changing the angle, those muscles are indeed getting longer, okay? And why is that? And so the reason that these muscles are getting longer as this knee flexes, that these are the antagonist muscles, okay? And so these muscles are actually not participating in the knee flexion because these are knee extenders, okay? And so as the opposite movement is performed, then the antagonist muscles, or the muscles that are on the opposite side, they have to lengthen, okay? But in contrast, if you were to extend the knee, and so if you were to bring the angle higher, then these muscles were shortened because these are the, muscles that are contracting to produce that movement. Okay. Okay. So you can see kind of the lengths of the muscles kind of change in that way. Okay, and that's exactly kind of what the plot kind of shows from here. Okay. So this is really interesting, and so this is something that you can do. If you were if you're doing let's say weightlifting analysis, right? One thing that you can do is that you can kind of simulate a movement by kind of incorporating the angle that the joint angle that changes throughout the movement, and you can see how that muscle fiber length is going to be changing throughout that movement. Okay. All right. Any questions on this so far? Okay. Good. All right. So another thing that's interesting here is that these plots are not constant, okay? And so these plots are kind of dependent on the particular pose that our model is undergoing, okay? Okay. So let's see how these plots are going to change when we change one of the other angles within the body itself, okay? So let me go ahead and show all of the muscles again, okay? So one nice thing is that you don't have to close the plotting window, so you can just kind of keep it open and just kind of keep doing your own thing in the main window here. Okay. Okay. So one thing I'm going to do here is let's go to the right hip flexion angle, okay, which is this angle right here. Okay, and let's change this angle to 45. Okay, so if you want to set this to a particular value, you can just use the text box next to it. So I'm just going to hit 45. If I had num lock turned on. Okay. So right hip flexion. Actually, let me set it to default again. Let's start from default, and then let me now change this to 45. Okay. Okay. So now our right hip is flexed by an angle of 45 degrees. So it's up like that. Okay. Now, because the model was in a different pose right here, that's going to affect the other muscles that are connected to it. Okay. Okay. So let's go ahead. Let me actually save this pose. So let me save this pose as hip 45. All right, and so let's go ahead and replot the muscles here. Okay. Bless you. Okay. Let me see if I remember how to do this. And so now that we move the model into a different pose, these plots should automatically update. So if I were to add these plots again, okay, you can see here that the muscles here updated, right? And so in particular, if you look at the rectus femoris muscle, this plot right here, right? This was the fiber length of the rectus femoris muscle when we were in the default pose. Okay. And then after we flex the knee at 45 degrees, you can see that overall, the line here kind of shifted downwards. And so this one here, this is our hip 45 pose. Okay. And so even if, it's, you're affecting the joint motion at a neighboring joint, that's going to affect the muscles in here, right? Remember, we talked about on Monday, this is kind of the concept of dynamic coupling, right? So basically the motion at one part of the body affects the motion at, the muscles at another part, okay? And it turns out that, it was a little bit hard to see, but actually the vastus intermedius muscle actually does not change. And so some muscles are kind of independent to particular poses. Some muscles are not independent. So you want to make sure that that your pose is what you want it to be. Okay. Okay. All right. And so, before moving on, so actually let me go ahead and close this. We're done with this plotter window for now. Okay. If you go through the PDF right here, you'll see that there are actually some conceptual questions here for you to answer. So I'm doing some of these. So I'm doing some of these together with you right now. But I am skipping some just for the sake of, just for the sake of brevity, just to make sure that we can kind of get through the entire thing. But if you're interested in learning more, definitely check out some of these questions, just because, they kind of show you different parts of the software. Okay. Okay. All right, so last thing that we're going to talk about today is we're actually going to simulate motion itself. We're going to animate motion, and we're actually going to use that to answer a clinical question. Okay. Okay, but we're just about done with this model, so let me go ahead and close it. Okay. So let's go ahead and close this model. So to close a model, you're going to make sure you have the model highlighted, and you're going to click on go to File, and then click on Close Model. Okay. This is really important. So, the model that we just used, we were just kind of using it for tutorial purposes. So don't save any information here. Okay. So you want to discard all of the changes. It's not that big a deal if you save it, you can always just kind of, reset. We didn't actually change any of the muscle lengths, but your extra poses will be saved and so forth. But, if you're going to save a model, try not to overwrite the current ones that are in the folder. Save it as a separate model, on your computer. Okay. Okay. All right. So for this next section of the tutorial, we're actually going to see how we can actually simulate movement. Okay. And kind of the context for this is actually a very interesting clinical question. And so I'm going to bring up the PDF here just so I can kind of describe it to you. Okay. Okay. So for this part of the tutorial, we're going to simulate something called a crouch gait. Okay. So crouch gait is kind of an abnormal gait pattern where a person is walking, and they kind of look like they're kind of crouching the entire time. Okay. So it's a very common walking abnormality, and it's particularly common among patients that have cerebral palsy. Okay. So you'll see it in a second, but the crouch gait is basically characterized by excessive flexion at the knee during the stance phase, and then exaggerated flexion and internal rotation of the hip. Okay. So this is kind of a very interesting phenomenon. So it's still kind of being studied by clinicians, but one hypothesized cause for crouch gait is this idea that the hamstrings of people with crouch gait are shorter than normal. Okay, and so because the hamstrings are shorter, it kind of places a lot of limitations on the complete range of motion that the person has, and so that's why they kind of have to walk with that crouch gait. Okay, so sometimes if a person has a crouch gait and it's kind of affecting their quality of life. Usually if you walk with the crouch gait, you're just going to put a lot of strain on your back, a lot of strain on your hips. So it's usually something that you want to address. So one kind of path to recovery is that surgeons will often recommend what's called a hamstring lengthening surgery. Okay, where they'll basically go in and they'll basically kind of manually kind of stretch the hamstring fibers to make it longer to help them fix their posture and improve their gait. Okay. The unfortunate thing is that that's not the only cause of crouch gait. And so some other causes are, maybe weak muscles in other areas. And so if you lengthen the hamstring, it could actually be bad for the person. clinicians and surgeons kind of have this question all the time of, we have this patient that has some kind of condition, how should we go about treating them? Okay, because different treatments will be more effective in certain situations. Okay. And so the clinical problem that we're going to be looking at for this last part of the tutorial is that we're going to be looking at the gait of a normal person walking versus someone that has crouch gait, and we're going to use the data there from the simulations to determine whether this person should have their hamstrings lengthened. Okay, so let's come back to OpenSim here. Okay, so first thing we're going to need to do is we're going to need to open a model. Okay, so just like we did earlier, we're going to click on File, Open Model. Okay. We're going to load actually the exact same model that we had before, which is the model of the lower extremity, which is perfect for studying the gait of a person. Okay, so let's go ahead and open up that model again. Okay, and so here's our skeleton dude, our armless skeleton, back again. Okay, but now in addition, we're going to load what's called a motion file. So a motion file is a file that contains basically motion capture data. Okay. Now this data has already been processed, and so it's kind of a very convenient form. Normally, if you have motion capture data, there's a bit of processing that you have to do, just like kind of what we learned in the class. But this motion capture data, just for the sake of brevity, it's kind of already been processed for you. Okay. So to load a motion file, you're going to come up to File, and you're going to click on the button for Load Motion. Okay. And so it's going to bring up another window here. Okay. And the type of file that includes the motion file is a .mot file. Okay. Okay. So luckily for us, a motion file has already been provided because this is a tutorial. So let's go into tutorial 1. Okay. And then inside this folder, there are various motion files. There's one for a normal gait, and there's a few motion files for a crouch gait as well. Okay, so let's start with the normal one. So let's go ahead and load the normal.mot. Okay. All right, and so what you should see is that first of all the muscles turn blue, and so that tells you that these muscles are going to be engaged with that motion. Okay, and if you go to the navigator window, you should see that there is a motion that is loaded under there. Okay. And which is the normal gait. Okay, so to play this motion file, we're going to go up to the toolbar at the top. Okay, the zoom thing kind of covers it a little bit, but it's the very top of the screen. So you should see. Actually, let me move the zoom thing down here. Okay, so at the very top of the screen, you should see kind of a list of kind of play features right here. So to play the animation in the forward direction, we're going to go ahead and click the play button. Okay. And you can see here that it simulates kind of a walking gait. Okay. So I believe this data here was actually taken from a person. So they actually had them rigged up with the mocap setup, and they kind of tracked his entire lower extremity. And this is kind of the result. Okay. If you want to loop the animation, that's usually pretty convenient just because you want to kind of see. There is a button for looping at the very far right here. Okay. And so we do that, you hit play, then this person is just going to walk in place just like that. Okay. All right. So that is a motion file. Where's my mouse? Okay. So that's normal walking, right? So let's see what a crouch gait looks like. So, the whole point of this study is that we want to kind of compare the normal gait with the crouch gait. Okay. So we want to basically load two models at the same time. And so we want to look at one which has the normal gait and the other which has the crouch gait. Okay, so let me go ahead and clear my drawings here. Okay, so to load a second model, there's really not that much extra that you have to do. So just like we loaded the original model, you're going to go up to File, Open Model. Okay. And I'm going to go one folder up. Okay. And you're going to open up the same gate 2392 OSIM model that we had before. Okay. The only difference is that for this model, we're going to load in a different motion file. Okay. So I'm going to go ahead and load in this other model right here. Okay. So you can see now our skeleton has a friend, right? So he has another armless skeleton to hang out with. Okay. You know, oh, before we load the other motion file, let's go ahead and rename these models, just because it's going to get confusing between the two. So this first model right here, this one had our normal gate. So to rename a model, you're going to go up to the navigator window. You're going to right click on the model name, which is kind of the first entry in the tree. And then you're going to click on rename. Okay. So for this first one here, because it has the normal gate, we're going to rename it to normal. Okay. And then for the second one here, because this one has the crouch gate, so let's go ahead and rename this to crouch. Okay. And let's load the motion. Let's load a motion file for this crouch gate. Okay. Now, one thing to keep note is that if you have multiple models loaded, you know, if you notice, one of these models here has its name bolded. And so if you look at the crouch gate, that one's bolded. And the reason it's bold is because this model is what we call the current model. Okay. So when you load a motion file, and oftentimes when you do other operations, usually those operations are only applied to whichever is the current model. Okay. And so you want to be careful. So so let's say that you're affecting the coordinates, or let's say that you're loading in a motion, you want to make sure that you're setting the current model to the one that you actually want it to do. Okay. Okay. So, just double check, make sure your crouch model here is the current one. And just like before, we're going to load in the motion. Okay. We're going to go into the tutorial folder, and we're going to load in the crouch one .mot. Okay. So there's actually several examples here of a crouch gate, so you can definitely view all those in your free time. But I'm just going to load in the first one right here. Okay. And so you can see here that the pose of the model is changed, and you can see here that he's more crouched down. Okay. Okay. So of course, one thing that you would want to do. So first, before we dive into the quantitative analysis, let's look and see how these two gates look side by side. Okay, so actually let me zoom in a bit just so you can kind of see. And so, if you hit play right now, the only motion that you're going to see is actually just the most current one. Okay. But you can actually view both models kind of moving at the same time. And so to do that, you're going to highlight both motions here from the left-hand side of the screen. So you can see we have the normal gate motion and the crouch gate motion. So you're going to highlight both of those. So you're going to hold Control on your keyboard and click, or if you're on Mac, I think it's you hold Command, okay, and click. You're going to right-click on this, and then you're going to click on the button for synchronize the motions, okay? Okay, so after you do that, you can see that both models have blue legs now. And so if you hit play, now you can see both models kind of walking together like that. Okay. All right. Any questions on that? Okay. All right. So this is cool, and so viewing the motions is always kind of very cool, and you can see it looks quite realistic. So you can tell that both of these were obtained from motion capture. Okay, so let me pause this just so we can stop looking at it. Okay, so that's great. So if you have a motion file, if you want to, if you're curious about motion files for your projects, of course, we don't have a motion capture setup here on campus, and so if one of the motion files that's included within OpenSim fits your situation, then that's great. You can feel free to use it. If not, then you can try looking online. And so OpenSim is open source, and so maybe people have published their motion files online. I haven't seen too many of those when I've tried to look, but it might be there. But it's if you want to do a motion sim like this, your options are unfortunately a little bit limited. Okay. Okay, so the last thing I want to do before we leave is let's see, let's do some plots here between these two. Okay, so plots are really useful just because they show you kind of a quantitative analysis, right? So this right here, where we're just looking at the videos, I would call this qualitative analysis. It's good for getting approximate results, but you can't really publish anything on qualitative data. Okay. And so whenever you're writing a formal report like you guys are doing, you need some quantitative data. Okay. Okay, so let's open up the plotting window just like we did before. So go to Tools and go to Plot. okay? Okay, so first thing I want to quantify here is the overall range of motion between the two different gates here, okay? And so range of motion refers to, how much, how much the joint angles are changing throughout the motion, okay? And so if you look at the normal gate, right? And so let's look at the knee angle in particular. You can see that the knee actually has a pretty good range of motion for the normal gait, right? And so during the stance phase, you can see that the knee kind of flexes this way, okay? And then during the swing phase, the knee extends, kind of fully. And so we have pretty good range of motion here. Whereas for the crouch gait, you can see here that the knee doesn't have a lot of range of motion, right? So it's kind of almost permanently locked into kind of this flex state. Okay, so let's quantify this and so let's see kind of the difference between those two ranges of motion. Okay, all right, so let's go ahead and we open up a plotter window. And so first thing we're going to do is we're going to plot the range of motion for the knee in the normal gait. Okay, okay. And so to plot range of motion, you're going to click on Y quantity here. Okay. Oh, excuse me. So actually, before we do that, you want to, since we're doing this for the normal gait, you want to make sure you switch the current model to normal. Okay, so I'm going to double click on normal up here. Okay. Okay. And so here for the Y quantity, we're going to go to normal gait. Okay. Let me do that again. And so for Y quantity, we're going to go down here. So because we've loaded a motion file, we can use that motion data as part of our plots. Okay. So we're going to click on normal gait under Y quantity, okay? And you can see here we can look at all of the different, kinematics of this motion here. So all of the different, joint angles we can kind of plot here, right? So of course, you can make plots for any of these joint angles here, but the one that we're going to do is for the right knee angle, okay? Okay, so go ahead and click the check mark next to knee angle R, hit OK. Okay. And under curve name here, we're going to change this to normal gait. Okay. This is just to label the curves because we're going to put multiple curves on the same point. Okay. Okay. Let's see. And so for the X quantity here, we want to plot the knee angle throughout the gait motion. And so for X quantity, you're going to click on normal gait. Okay. Oops. Let me change the name again. Okay. All right. So let's go ahead and add this to the plot. And so by adding it to the plot, you can see here that this plot here shows you the knee angle, as a function of the gait cycle. Okay. Okay, so now let's do the same thing for the crouch gait. So, we're going to repeat the same operations, but we're going to switch our current model to the crouch gait. So let's double click on crouch. Okay, make that our current model. And we're going to do just the exact same thing. So for Y quantity here, we're going to go click on crouch gait. Okay. We're going to look for the knee angle R. Okay. X quantity, we're going to plot this against the entire gait cycle. Okay. And then I'm going to rename this to crouch gait. Okay. Okay. So before I add this, let's kind of stop and kind of think about, what we expect from this plot here, right? So what we know, or what we kind of see here from the image, is that for the crouch gait, the knee angle is kind of more or less fixed, and so it doesn't really have any range of motion. And so when we plot this, it should show that the knee flexion angle is going to be low for the crouch gait. Okay. Okay, so I'm gonna go ahead and add this. And you can see here for the blue curve, so the blue curve, let me maximize this. The blue curve is the knee flexion angle, for the crouch gait. And you can see that indeed, it has much more range of motion. So the difference between the peak and the valley here is very small. And you can see here that the entire knee is actually overly flexed, okay? And so that's why the entire plot seems to be kind of, displaced down near the bottom. Okay. And so this kind of confirms kind of what we saw qualitatively in the motion, that the knee for a crouch gait is more or less kind of locked into place. Okay. All right. Any questions on that? Okay. All right. So the last thing that we're going to show here kind of goes back to our original question, right? And so go ahead and close the plotting window. We're done with that one for now. Okay. And so the original question that we had asked is that, for this person that's walking with this crouch gait, we want to develop some kind of treatment for them because, they can't, walking around like this is not something that's sustainable for the long term, right? So, one possible treatment for this is to lengthen their hamstring muscles, okay? So basically take their hamstrings down here and just make them longer, okay? And so if we can show through this simulation that this person has, abnormally short hamstrings throughout the motion, then we can say that, yes, this person can benefit from hamstring lengthening surgery, okay? But let's actually plot that to actually see if that's the case. Okay, so let's come back up the tools here. Let's go back to plot, okay? Let me maximize this just so you can see everything, okay? Oh, actually, let's go back here. Let's look at the normal first. So once again, make sure that your current model is set to normal, okay? And so this is going to be a plot that's very similar to our first one. So remember, the first plot that we made today was a plot of the muscle fiber length, okay? We're going to do a very similar here, but we're also going to include the tendon as well, okay? And so first thing you're going to do is you're going to click on Y quantity here, okay? And you're going to click on muscle tendon length. And so this is the total length of both the muscle and the tendon. Okay. Okay. All right. And so the particular muscle that we're going to look at here is the hamstring muscle. So hamstring is made up of a lot of muscles, but the main one that we're going to be doing is the semitendinosus muscle. Okay. And so I think the easiest way to do that so the easiest way to find this is to, once again, search by muscle group. And if you go under right knee bending, you can see here that there is a muscle here called semi-10. Okay. So it's semi-10R. Okay. So let's go ahead and select that. Make sure there's a check mark there and click close. Okay. And then for the X quantity here, we're going to plot this across the normal gait, just like we did before. Okay. So we're going to look at the length of the hamstring, total length of both the muscle and the tendon, throughout the gait cycle. Okay. Right. Actually, before we plot it, let's make sure we have this labeled. So I'm going to change this to normal gait. Okay. And then hit add. Okay. Okay. So from this plot here, you can see that we've plotted the length of the hamstring as a function of the normal gait. And so you can see the hamstring muscle, gets shorter, and then it comes longer again right here. Okay. Now let's do the exact same thing for the crouch gait. And so if we can show that for the crouch gait person, that their hamstring muscle is, much shorter than these ones. So if the plot is kind of, much further down, then this person can benefit from hamstring lengthening surgery. Okay. So let's come back to OpenSim and let's go ahead and double click on crouch gait. Okay. So make sure the crouch model is your current one. And once again, we're just going to do the exact same things as before. So we're going to plot the muscle tendon length. We're going to look for the semitendinosus muscle. So that is under right knee, right knee bend. Okay. We do semi-10, click close. X quantity, we're going to plot it against the normal gait. Let's label this crouch gait. Okay. Okay, so let's go ahead and click add. Okay. And in blue here, you can see the hamstring length of the person, with the crouch gait. Okay. And so you can see here that the maximum length of the crouch gait person's hamstrings is indeed shorter. And so you can see here that, for the normal gait, it reaches a maximum length of about 0.48 meters. And then for the crouch gate, this reaches a maximum length of about 0.475. So there is a gap here, okay? For the valley here, you can see that they're roughly about the same, okay? But it's usually up here where there's kind of a big difference, okay? And so because there is a difference up here in between, you know, the maximum hamstring length throughout the motion for a normal gait versus a crouch gait, then we can say that yes, you know, this person could benefit from a hamstring lengthening surgery, because this is, you know, a little bit abnormal. So it's about, you know, they're about kind of 10 centimeters off from each other, which is, you know, pretty kind of significant a little bit, okay? Or excuse me, not 10 centimeters, just 1 centimeter apart, okay? Which for a muscle is actually pretty big. Okay. All right, any questions on that? Okay, all right, so that is an introduction to OpenSim, and so that kind of concludes the tutorial. So remember, you know, that website that I linked in the original email, not the SimTK one, but the link with the examples. You know, there are a lot of other examples here for you to try out. So the one that we just did was just tutorial 1, which is just a basic introduction to musculoskeletal modeling, okay? But you can see here, there are a ton of other examples for you to try as well, okay? So for instance, you know, if you want to see how OpenSim does inverse kinematics and inverse dynamics, you can look at tutorial number 3, okay? This is kind of a really interesting one. So this kind of shows you how to actually take raw motion capture data and actually run that through the model, okay? If you want to see an example of an actual kind of, you know, an actual kind of study, you can look at a soccer kick, okay? So you can see how that's done. And then there's some intermediate examples here. So you can see there's some with optimization, you know, some design studies here. And so, you know, designed to help prevent ankle injuries, okay? And some more advanced ones here as well. So these more advanced ones kind of factor in MATLAB to kind of, you know, you kind of run MATLAB and OpenSim kind of in parallel with each other, okay? All right, and so that's OpenSim. So, you know, I know it was kind of very quick, but, you know, even just the basics, you know, there's a lot of features here that you can use for your final project. And, you know, this kind of sets the baseline for kind of all the other features that OpenSim has, you know, which is kind of outlined in these tutorials here. Okay, so I hope you guys enjoyed that. You know, hope you know, that was kind of fun. You know, even if you have no intention of using OpenSim for your final project, you know, even just, you know, looking at these skeleton dudes and seeing them walk, you know, hopefully that was kind of entertaining for you, okay? So since, you know, since this is kind of the last lecture that we're gonna have together, so next week is gonna be all you guys. And so, you know, you guys are gonna be giving presentations. So I wanna take this opportunity to say thank you guys for a great semester. You know, it's kind of no secret. So I've told some of you guys that, you know, I haven't really been feeling that great about this job. You know, we have kind of a really crappy provost and, you know, my dean kind of hates me, but so I've been feeling very negative about this job, but especially coming into this semester. So, but, you know, one thing I always really enjoy is I really enjoy teaching you guys. I enjoy talking with you guys. You know, even if you're just a name on a screen on Zoom, you know, I'm glad that you're here listening to me yap about biomechanics for an entire semester. So thank you guys for a great semester. Thank you guys for being great. Remember to fill out your SOQs, so don't forget to do that. And I'll see you guys next week for your final presentations.
Will you still be holding office hours today?
Yes, yeah.
Right,
So I'll be
perfect.
holding office hours today, tomorrow, and all of next week, and the following week after that too. Yep.
All right, perfect. Thank you.
Yep.
Would this count as office hours right now then, Professor?
Sure, yes. Did you want to talk privately or is this okay?
I assume this is okay since I don't think anyone's gonna join necessarily.
Well, I mean, there's still people in the classroom.
Oh, okay, never mind. Yeah, then privately would be better, yeah.
Okay, yeah, let me get back to my office. Go ahead and join the stay on this call right here. I'll rejoin this in my office and we can talk privately.
Okay, sounds good.
Yeah. Mm-hmm.